Hi kids! Okay, we're jumping right in. This is Module 4, Lesson 17, and it's a big one, and it's a really important lesson for your understanding. So let's take a look. The objective is to relate decimal and fraction multiplication. So in the teacher's edition, it always starts out with some little warm-up problems, and that's what this is, just multiplying fractions, numerators times numerators, denominators times denominators, and you get your final product. And so have a little bit of this, and hopefully your teachers will do that with you. But it gets down to the important part where we're going to tie in some equivalents. Now, when you have equivalent fractions to decimals, what you have is the place value position's name on the bottom. So look at the place value position's names. This is to the right of the decimal. The first place to the right of the decimal is the tenths place. Tenths means 1/10, 1/10 of 1. Every number on the place value chart that is to the right of any other position is 1/10 of that value. So I could divide by 10 and get the number that would go here. Divide this by 10 and get that same thing here. So that's how the place value system works, okay? Now we're really tying in, this goes back to Module 1, Lesson 1. So 1/10 is equal to 0.1, and 2/10 is equal to 0.2, and 8/10 is equal to 0.8. So what happens when you get into hundredths? Well, that's fine. You just have to remember to put the digit in the position of that name. So if this is 1/100th, then the 1 goes in that hundredths place. Tenths are first to the right of the decimal, then hundredths, then thousandths. So when you see 12 hundredths, it's going to be 0.12. The 2 needs to end or be located in the hundredths position, which is the second position. So we go on, and we have a little bit more warm-up. 45 100ths equals 0.45. 93 hundredths equals 0.93. What about a number like this? This is an improper fraction. It's a fraction greater than 1, 406 hundredths. Well, what that is I'm still going to have the 6 finishing in the hundredths position, and I would read it 406 hundredths, because you know you can rename, you can take the decimal out. Well, you have to know where the decimal is, but you don't have to have it in this fractional problem. So 406 hundredths would be 4.06, or 406 over 100. So then we take that idea and we have, okay, well, let's multiply some whole numbers by decimals and see what we get. And we've got word form and we have decimal form. So 2 times 1/10 would be 2/10, because we're just multiplying the 2 times the 1. That's where you get the 2. But remember, this is a fraction of a whole number, so I should have a fractional answer. So if I wanted to write this in a fraction, it would be 2/10. You're probably noticing the ace bandage. Yes, let's just say I fell down. It didn't feel good. And then we're going to move on. Hopefully in a few weeks I will not have to wear this anymore. Anyways, it goes on. So look at the next one. 7 times 1/100th. 7 times 1 is 7, but it's hundredths. Don't forget to put the 7 in the hundredths place. So all this is very, very important, critical for today's lesson, understanding place value. Okay, place value positions, tens, ones, decimal, tenths, hundredths. So if you take some more examples, 1/10 times 4 equals 1/10 in fraction times 4, which you know is 1 times 4, which would give you 4 over 10, 4/10. Now today's lesson, it's going to be critical that you don't simplify. Don't simplify today. You're probably saying, well, I could simplify that and change it, make it so much easier. Yes, you could. But the problem with simplifying today is that our end goal is to connect these fractions to decimals. And we can't connect fractions that are fifths or halves to a decimal position without scaling it to something else. So we don't want to simplify today. We just want to use the fractions as they are. Why? Because we're going to do this cool thing eventually, and that's what today's lesson is looking at, well, what does this represent? Okay, so if this is one thing, if I take 1/10 of it, shade one way. Sorry, I already worked this through, but if I take 1/10 of it, it would be 1 out of 10 vertical columns, okay? 1/10 would be this whole thing here, just one of them, not this one too, because that is its own tenth. That makes 2/10. 1/10 plus 1/10 makes 2. So just look at 1. If I take 1/10 of that tenth, that would be this one. So remember when we do our models and we have these cross shading, that's what we're going to end up with for our decimal answers today. So it's really important. There's so much in this lesson, taking fractions and relating them to decimals. And so we're going to do both. We're going to have fractions, we're going to have decimals, we're going to show both ways so that you can see those. So that is what today is all about. And I'll try to write my neatest. And if you want to have some colored pencils to kind of help you see the crisscrossing, remember how they do the double shade, but we're not going to do the double shade. So ideally what this would be is this would be the shading one direction, and then this would be the shading the other direction. Okay, but the only place that matters, the answer, is where they crisscross and where that double shading is. So we're going to multiply and model. We're going to rewrite each expression, this is an expression, as a multiplication sentence with decimal factors. This is the, and I can't divide it, the whole thing just yet. This is the multiplication sentence with decimal factors. Remember, a factor times a factor equals a product. Okay? Factors. Nothing more than numbers we're multiplying. The first one is done for you. 1/10 times 1/10 equals 1/100th. And we're going to follow this same pattern of taking the numerators, make one fraction, solve, and remember, don't simplify. Take the fractions, write it as a decimal, and then write the answer as a decimal, thinking about place, value, position. Let's do part B. Okay, so we have 4/10 times 3/10. So what you want to do is you want to show the 4/10 in shading. I'm going to do my best to make this neat. Okay. So this is all one way, and this is where if you want to use like a colored pencil, you can also just do a colored pencil for one section, and then the crisscrossing is going to be where they overlap. Okay, so that's 4/10, and we're going to put this over the 10 times 10, and so the next one is 3/10, so that's going to be the crisscross model this way. Okay, so if you have your crisscrossing, then this would be the 3/10. Now, how many are in this double shaded section? That's 12. Out of how many? 10 times 10 is 100. And so I know my fractional answer is 1200, so what does that look like as a decimal? So we're going to take our 4/10 and write it as a decimal. Remember, the tenths are the first position to the right of the decimal. Multiply by 3/10, which is the first position. Now 4 times 3 is 12, so I can go ahead and write my 12. I know that's the answer, but where does the decimal go? Okay, now in the warm-up, there were a couple problems. I probably just glossed over them really fast. These are the problems that are going to be kind of helpful to today's work. So if you have 1/10 times 1, you get tenths. Okay, but if you have tenths times tenths, you get hundredths. So you want to really keep an eye on where, if I have a double-digit factor, where does my decimal go? So if I have 12 tenths times 1/10, I'm going to end up with 12 hundredths. And so that goes to our tenths times tenths equals hundredths. So that means this position and this position are to the right. And so you want to back that up and have a 0 before the decimal so that the 12 will end in the hundredths place. Okay? Hopefully that is neat. Sorry, it's probably like autofocusing all over the place. Okay, C. So 1/10, now they're going to mix it up and give you 2. Focus, please. Focus. They're going to give you a fraction and a decimal. Thank you for focusing. It's very kind. So we're going to do 1/10 of 1 and 4/10. So why couldn't I do this before? Because I have to shade one whole and 4/10 of another. Okay, so let's say you've got your yellow pencil. This whole thing is represented by the 1 in the ones place. Okay, so all these are the right side slashing. So I need 1/10 of that. So what is that? Well, let's just go down here like they did on the bottom. And I'm going to take 1/10 of that. But it's 1/10 all the way across. Because it's 1/10 of the whole entire thing. So let's turn this into a fraction. Now, what would this look like? So it would be 14 tenths. Could you do 1 and 4/10? Yes, you could. And then 10 times 1 is 1 plus 4 is 14, and then 14 over 10. So 1 times 14 over 10 times 10 gives you 14 hundredths. Now that's your fractional answer, but what does this look like? And again, they don't give you very much room, but we're going to take 1/10 of 1 and 4/10. So 1 times 14, I know that's 14. But I have tenths times tenths, and that gives me hundredths. And so you can put your 0 to the left of the decimal. And this place value matters so much. It's really, really critical that you get those right. Okay, so only in the double shaded places, look, here's 10, and here's 1, 2, 3, 4. That's 14 in the double shaded. Out of 100, out of a unit that's 100, remember it's all about what the unit is, so same thing would happen with fractions. If the unit is greater than 1, it's still what the unit is for 1, and the unit is 100. Okay, that's probably not very clear, but we'll try to keep doing it so you can see. More practice. Okay, 6/10 times 17 tenths. It's tenths because the 7 is in the tenths place. So what does that look like? 17 tenths. That's going to be all of 1 and 7 more. Now this is going to be the 1, 2, 3, 4, 5, 6, 7. Stop. Be very careful. Only get 7. I'm like not very careful here. That's okay. Okay, and then we need 6/10 of that. That's going to be 1, 2, 3, 4, 5, 6. So we're going to go everything down below that line on both. But the answer is only where it's double shaded. So I have 6 times 17 over 10 times 10. And for 6 times 7, 42, and 102 over 100. So we end up with 102 hundredths as our fraction. which I don't recall if they want it to be like 1 2/100 or if you can just leave it like that. But it doesn't really matter that much because the end goal for today is to multiply 6/10, our decimal values, times 1 7/10. And so 6 times 17, you've already done the work. You know that it's 102. But the real work on the decimal is where do I put the decimal? So it's 102 what? Tenths times tenths equals hundredths. If you put your decimal place here, that's tenths, and this is hundredths. So it's all about placing everything in the right spot, okay? Now I could count these, all these double squares, and I would get 102. And if you count them, you should get 102 as well. But you have to shade carefully so you can do that right. Okay, next page. Multiply. The first few are started for you. Now, first of all, please notice 5 times 7, 5 times 7, 5 times 7. 6 times 3, yes, again, 12, 12 and 4, 12 and 4. Okay, it's the same numbers. We're just moving the decimal around so you guys can get really good at placing the decimal. We're going to do this in this format. It's kind of started, so they've got this little scaffold, so we'll just fill in the blanks. All right, 5 times 7/10. So you're going to copy, you've got your whole number, and then you change it to a decimal. Take your numerators and put them in a fraction over the denominator, which hopefully you can just multiply that through on the first one. Oh, nope, they want us to do it by breaking it out. Solve the top over the bottom and then change it to a decimal. This, we're going to put a line there because there's not going to be very much room for your answers for the next row. This one's totally done, and I don't care if you fill it in on the line. You can if you want to. So 5 tenths times 7 tenths, 5 times 7 is, we already know the answer, it's 35. But this denominator is different. Okay, so it's 35 hundredths. So what does that look like as a decimal? It looks like the 5 in the hundredths place and then work backwards, 35, 0.35. Okay, so they give us even less here. So if I have 5 in the hundredths place, this is going to be massive review for decimals. We haven't done this in months, but 5 hundredths is our first value. 7 tenths is the second value, the second factor. 5 times 7, still on the top, but 100 times 10 on the bottom. We still have the same answer, 35 over 1,000. 100 times 10. Now, 35 thousandths is going to end with, okay, tenths, hundredths, thousandths. Just put in the lines and fill in the digits. Our answer, 35, didn't change. Only the place value position changed. First, it's 35 tenths with 5 in the tenths place. Then it's 35 hundredths with 5 in the hundredths place. Then it's 35 thousandths with 5 in the thousandths place. Very important to shuffle it over. And again, don't simplify any of these. If you move away and you don't end up with tenths, hundredths, thousandths, then it makes it more challenging. There's just more steps that you have to do to get that fraction to fit as a decimal. Okay, now here's the real work. We don't have any scaffolding done for us, but that's okay. We don't really need it. Take that 6 and copy it, and then change the decimal to a fraction. 3 tenths. Okay, now take this and put your whole numerator over the denominator of 10. Then solve it. 18 tenths, and it's just so squeezy in here. Why don't they give us more room? And then below that you would have 18 tenths. Now, in the same way that you have to bump it into the ones place, you have to end with the 8 in the tenths place, okay? It has to be here, so the 1 has to be to the left. So you end up with 1.8, 18 tenths. Let's do another one. 6 tenths times 3. I am so glad I can write. Like, oh, what a stressor. And then this is 6 times 3 over 10 times 10. And then we have 18 over 100 this time, because 10 times 10 is 100, which then below that would be 18 hundredths. Now that's different from this one. 18 ends in the hundredths place, 0.18. Okay, different. This one we have even different factors, okay? They've moved the 6 over another spot. So it's not 6 tenths, it's 6 hundredths times 3 tenths. So they didn't move the 3 this time. They didn't move the 3 at all either time. And then we have, I should do this step where we write it all out, 100 times 10. And so we have 6 times 3 is 18 again, but 10 times 100 is 1,000. So where do we put the 18? It's going to be 0.018. I hope you were thinking that, because the 8 needs to end in the thousandths place. Tenths, hundredths, thousandths. Okay? All right. Next one. You guys are doing great. So we know that 12 times 4 is 48, but where are we going to put the decimal? And how do we do this? All right. 12 tenths times 4. Well, gosh, 4 is a whole number, so I can have 4 over 1. Okay, you can leave it as a whole number 4 if you want, because we're going to do this as our next step. 12 times 4 over 10. And now we have our 48 tenths. And that would give us 48 tenths. Remember, I have to end here. So 48 tenths. 8 in the tenths place, 4.8. Next one, we have 12 tenths again, but this time instead of 4 ones or 4 as a whole number, it's 4 tenths. So 12 times 4 over 10 times 10. Don't simplify, just multiply. 48 over 100. Instead of 48 tenths is 48 hundredths, which is going to give you 0.48. And finally, 12 hundredths times 4 tenths. We have 12 times 4 on the top still, but 100 times 10 on the bottom. And that gives you 48 over 1,000. And that means 0.048. Finish with the 8 in the thousandths place. Really hit that THS on the end. Okay, we're almost done. A Boy Scout has a length of rope measuring 7/10 of a meter. He uses 2/10 of the rope to tie a knot at one end. How many meters of rope are in the knot? The 2/10 in the knot. It's going to be 2/10 of 7/10 meter. Okay, so 2/10 of 7/10. So put this into a fraction to see how those are the same. If you have 14 hundredths, because I'm going to go ahead and multiply across, you can show that in decimal form. It doesn't really specify here on these. Sorry. Oh, yeah. Oh. That was a little too fast. Quick movements are never good. So 14 hundredths is here, 14 hundredths is here, and this is going to be meters. Okay, in the knot. Cannot. Oops, there go the lights. Hello, we're almost done. After just 4/10 of a 2.5-mile race was completed, Lennox took the lead and remained there until the end of the race. Good job, Lennox. Got first place. How many miles did Lennox lead the race? So we've got, after the 4/10, what would be left? So you can always make tape diagrams with both of these, okay? Out of the tenths and the 2.5-mile race, like you can do the whole 2.5 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pretend that they're all the same. After the 4/10, Lennox took the lead and remained there. This is how much he led. So if you need to see the picture that this is the 6/10 to get this, you can do what you need to do. It doesn't say that you have to, but do what you need to do. So 6/10 of 2.5-mile race. And I can turn this into a fraction. So 6/10 of 25/10. Remember, this is the place value position where, oops, there you go. Sorry, that was kind of low. This is the place value position of the denominator, so tenths. And then don't simplify, just multiply so you can get the decimal answer too. So pretend these are quarters. If you had 4 quarters, you'd have $1. So if you have 6, you have 150. And 10 times 10 is 100. So if you have 150 hundredths, then it can look like this. This is the 150. This is the hundredths position. And so how many miles did Lennox lead the race? 1.5 miles. And so if you just put 1.5, you're fine. That's equivalent. It's fine. And, ooh, we should probably wrap this up. Reed, the second place finisher, developed a cramp, bummer, with 3/10 of the race remaining. How many miles did he run without the cramp? And again, if it's 3/10 remaining, then it's 7/10 without it. And you can do that with the whole race minus the 3/10 that was remaining to get the 7/10 that he ran without the cramp. But they don't want to know, they want to know the miles. So it's going to be the 7/10 of the 2.5 or 25/10. So I'm going to use the same fraction I used up here. And instead of 6 times 25, I need 1 extra 25. So instead of 150, I would get 175 hundredths. See how I'm using the work I already did? And that would turn into 1.75 miles. So I hope this is super helpful. You guys are awesome. Click to subscribe, and I'll see you on the next one. Bye.